Hi everyone, we are the Group 5 and we will tackle the topics about engineered nanomaterials. Here are the contents of our report. First is the introduction of nanomaterials. Next is example of nanomaterials. Then advantages and disadvantages of nanomaterials. Uses of nanomaterials, application of nanomaterials, purpose of nanomaterials, and lastly, the properties of nanomaterials. I am Joris Torcolas and I will report the introduction of nanomaterials. Richard Feynman, an American physicist, is considered to be the father of nanotechnology. Long before the term nanotechnology was developed, on December 29, 1959, physicist Richard Feynman gave a lecture titled "There's Plenty of Room at the Bottom" at an American Physical Society meeting held at the California Institute of Technology, or Caltech. In his lecture, Feynman laid out a method through which researchers will be able to control and manipulate specific atoms and molecules. Professor Norio Taniguchi introduced the term nanotechnology more than 10 years later while researching ultra-precision processing. Modern nanotechnology didn't start until 1981 with the invention of the scanning tunneling microscope, which could see individual atoms more than 4,500 years ago. Humans began taking advantage of the strengthening of ceramic matrix by incorporating natural asbestos nanofibers. Based on a synthetic chemical method, the ancient Egyptians were also using NMS more than 4,000 years ago to create materials with a diameter of about 5 nanometers for hair color. Similarly, Egyptian blue was the first synthetic pigment which was manufactured and used by Egyptians using a sintered mixture nanometer-sized glass and quartz around 3rd century BC. Egyptian blue is a complex amalgamation of quartz and glass. Archaeological research has revealed that Egyptian blue was widely used for ornamental purposes in ancient Roman Empire regions, including nations like Egypt, Mesopotamia, and Greece. Nanomaterial is a material with any internal or external structures on the nanoscale dimension. The prefix nano is referred to a Greek prefix meaning dwarf or something very small and depicts 1,000 millionth of a meter or 10 raised to negative 9 of a meter. Nanomaterials are usually considered to be materials with at least one external dimension that measure 100 nanometers or less, with external structures measuring 100 nm or less. A nanometer is 1 millionth of a millimeter, approximately 100,000 times smaller than the diameter of human hair. According to their origin, sources of nanomaterials can be divided into 3 main categories. Number 1, incidental nanomaterials, which are created accidentally as a byproduct of industrial processes like nanoparticles produced from vehicle exhausts, welding fumes, combustion process, and even some natural processes like forest fire. Number 2, engineered nanomaterials, which have been created by humans to have specific required properties for desired applications. And the last one, number 3, natural nanomaterials, the lines between produced, incidental, and naturally occurring NPS, however, are frequently modeled. For instance, incidental nanomaterials may occasionally be regarded as a subset of natural nanomaterials.
So, hello guys, I'm Andrew Kevin Pautrao. Example of nanomaterials and the industries they are used in. Nanomaterials are materials that have at least one dimension in the nanometers range 1 to 100 nanometers. They have unique physical chemical and biological properties that make them attractive for a wide range applications. So here's some example of nanomaterials include in. So the number one is carbon nanotubes. So carbon nanotube or CNTs are cylindrical structure made of carbon atoms arranged in a hexagonal lattice pattern. They have a very small diameter, typically ranging from a few nanometers to a few micrometers and can be several millimeters long. CNTs can be single-walled or multi-walled, depending on the number of concentric tubes that make up the structure. They are known for their exceptional mechanical, electrical, and thermal properties and have a wide range of potential application in fields such as electronics, energy storage, and medicine. And the next one is silver nanoparticles. Silver nanoparticles are tiny particles of silver with a size range of 1 to 100 nanometers. They are commonly synthesized through various methods, including chemical reductions, physical vapor depositions, and electrochemical synthesis. Silver nanoparticles have unique physical and chemical properties such as high surface area, high reactivity, and antimicrobial properties which make them attractive for various applications, including biomedical, environmental, and industrial fields. In biomedical applications, silver nanoparticles are being explored for their potential use in drug delivery, cancer therapy, and wound healing due to their antibacterial and anti-inflammatory properties. In the environmental field, silver nanoparticles are being used in water treatment to remove pollutants and bacteria. In the industrial sectors, silver nanoparticles are being used in electronics, textile, and coatings for their unique properties. And the next one is titanium dioxide. Titanium dioxide nanoparticles are particles of titanium with a size range of 1 to 100 nanometers. Titanium dioxide nanoparticles is naturally occurring mineral that is commonly used as white pigment in various products such as paints, plastic, and cosmetics. Titanium dioxide have unique properties including high surface area, are photocatalytic activity, and antimicrobial properties which make them attractive for various applications including biomedical, environmental, and industrial fields. In biomedical applications, titanium dioxide are being explored for their potential use in drug delivery, cancer therapy, and dental implants due to their biocompatibility and antibacterial properties. In the environmental field, titanium dioxide nanoparticles are being used in air and water purification to remove pollutants and bacteria. In the industrial sectors, titanium dioxide nanoparticles are being used in solar cells, coatings, and self-cleaning surface due to their photocatalytic and superhydrophilic properties. And the next one is quantum dots. Quantum dots are tiny semiconductor particles with size range of 2 to 10 nanometers. They have unique optical and electronic properties that make them attractive for various applications, including imaging, lighting, and sensing. Quantum dots are typically composed of elements from their periodic table such as cadmium, zinc, and selenium, which are chosen based on their ability to emit light in a specific color range. Quantum dots can be prepared can be engineered to emit light in a range of colors from ultraviolet to infrared by controlling their size and compositions. In imaging applications, quantum dots are being explored for their potential use in medicines, where they can be used to visualize biological structures and detect disease. In lighting applications, quantum dots are being used to produce more efficient and brighter light sources. In sensing applications, quantum dots are being used to detect small quantities of analytes such as proteins or chemical in samples. And the last one is graphene. So graphene is two-dimensional material made of carbon atoms arranged in hexagonal lattice pattern. In the tiniest and stronger materials known with a thickness of only one atom and textile strength more than 100 times greater than steel. So here's some example of graphene. Electronics. Graphene is being explored for their potential use in ultrafast transistors, flexible display, and high-performance sensors. And the next one is energy storage. Graphene is being used to develop high capacities and batteries and supercapacitors due to its high surface area and electrical conductivity. And the next one is biomedical engineering. Graphene is being explored for drug delivery, tissues engineering, and biosensing due to its biocompatibility and unique properties. And the next one is aerospace. Graphene is being used to develop lightweight and durable materials for aircraft and spacecraft. Automotive. Graphene is explored for its potential use in fuel cells, energy storage, and lightweight materials for cars. And the next one is construction. Graphene is being used to develop stronger and more durable materials for construction. And the next one is water filtration. Graphene based on membranes are being developed for water filtration and desalinations. And the last one is sports equipment. Graphene is being used in sport equipment such as tennis rackets and bicycles to make them stronger and lighter. Overall, graphene has the potential to revolutionize various industries by offering new and improved materials, devices, and technologies. However, for their research, it's needed to fully understand and optimize its properties and potential applications. So, next slide please.
Advantages. 10 ways nanotechnology impacts our daily lives. The benefits of nanotechnology aren't limited to scientists and engineers, though these 10 ways that nanotechnology impacts our lives on a daily basis. First, faster, smaller, and more powerful computers. Nanotechnology contributes to compact, efficient computers that consume far less power and use long-lasting batteries. Circuits made from carbon nanotubes could be vital in maintaining the growth of computer power. Second, faster, more accurate medical diagnostic equipment. With a lab-on-a-chip technology enabling point-of-care testing in real time, nanotechnology helps to speed up the delivery of medical care. Additionally, nanomaterials surface on implants improve wear and resist infection. Third, Improved pharmaceutical products. The use of nanoparticles in pharmaceutical products makes them easier for the body to absorb and easier to deliver, often through combination medical devices. Nanoparticles can also deliver chemotherapy drugs to specific cells, such as cancer cells. Fourth, improve vehicle fuels efficiency and corrosion resistance. By building vehicle parts from nanocomposites, materials that are lighter, stronger, and more chemically resistant than metal. Nanotechnology helped to improve fuel efficiency and corrosion resistance. Nanofilters remove nearly all airborne particles from the air before it reaches the combustion of chamber, further improving gas mileage. Fifth, stain-resistant, water-resistant, and flame-resistant fabrics. Nanoparticles or nanofibers in fabrics can enhance stain resistance, water resistance, and flame resistance without significant increase in the weight, thickness, or stiffness of the fabric. For example, nano whiskers on plants make them resistant to water and stains. 6. Improve water quality. Water filters that are only 15 to 20 nanometers wide can remove nano-sized particles, including virtually all viruses and bacteria. These cost-efficient, portable water treatment systems are ideal for improving the quality of drinking water in emerging countries. 7. Stronger, lighter, weight sport equipment. Carbon nanotubes have a variety of commercial uses, such as improving the design of sport equipment. For example, a tennis racket made with carbon nanotubes bend less during impact and increase the force and accuracy of the delivery. Nanoparticle-treated tennis balls can keep bouncing twice as long as a standard tennis ball. 8. Reduce UV exposure. Most sunscreen today are made from nanoparticles that effectively absorb light, including the more dangerous ultraviolet range. They also spread more easily over the skin. These same nanoparticles are also used in food packaging to reduce UV exposure and prolong shelf life. 10. Enhance surveillance and security systems. Thanks to nanotechnology, a huge variety of chemical sensors can be programmed to detect a particular chemical at amazingly low levels, for example, a single molecule out of billions. This capability is ideal for medical fraud. Nanosensors can also be used to accurately identify particular cells or substances in the body. 9. Increase shelf life of plastic bottles. Many drink bottles are made from plastic containing nanoclays, which increase resistance to permeation by oxygen, carbon dioxide, and moisture. This helps retain carbonation and pressure and increases shelf life by several months.
If there is an advantages of nanomaterials, there are also disadvantages. So first, one of the main disadvantages associated with nanomaterials is considered to be inhalation exposure. So it means that nanomaterials can be a risk to our health because some of nanomaterials such as carbon nanotubes and nanofibers, it may cause pulmonary fibrosis. And any other health risks are ingestion exposure and thus explosion hazard. So next, there are still knowledge gaps regarding nanomaterials, meaning that manufacturing process can often be complex and difficult. Experts need more knowledge and conduct more research in order for the manufacturing process to become more easier and less difficult. Next, the overall process is also expensive. So how did it become expensive? So nanomaterials is not an ordinary material that can be seen or found everywhere. So that's why it is expensive. So for example, the gold production. So the cost of gold nanoparticles production, it costs 80,000 US dollars per gram. So when we convert it in Philippine peso, it cost 4,300,000 and something. So imagine how expensive it is. So next, risk assessments concerning any potential environmental effects indicate that nanomaterials used in cosmetic items such as sunscreen, which are applied to the skin, run the risk of ending up in aquatic ecosystems after they are washed off. So we all know that there are so many living organisms in our aquatic ecosystems. So it can be harm for them, and it may result disappearance of our different species. Uses of nanomaterials: healthcare, drug delivery. So one of the example of this is transdermal. Antibacterial bandages. So these bandages kills bacteria to help prevent infections. Cosmetics, sunscreens. Food sector, food packaging and food sensing. Water purification, filter, membranes and adsorbents. Electronics, nanostructured semiconductors which show nonlinear optical properties also exhibit special properties like luminescence. So what is luminescence? Luminescence is an emission in the optical range of the visible, ultraviolet, or infrared light. Sports, lighter baseball bats and tennis rackets. Agriculture, nano fertilizers and nano pesticides.
Applications of nanomaterials in medicine. Nanomaterials are used in targeted drug delivery to increase the absorption rate and the solubility of indissoluble drugs and reducing its dosage. Nanomaterials are also used to reduce the side effects of drugs or medicines. Nanomaterials are also used in early diagnostic of diseases by the use of nanoparticles that clamps together when attached to protein or other molecules that indicates diseases that are being tested for. In electronics, nanomaterials are used to reduce the power consumption of electrical gadgets by using the nanotechnology improved display panels. Nanomaterials are also used to lessen the size and the weight of the electronics components. It is also used to create smaller and faster processors for electrical gadgets. In energy, nanomaterials are used to reduce the cost of catalyst in fuel cell. It can increase the efficiency in solar cells, and it also increases the energy density in a battery. In space technology, nanomaterials are applied or used in lightweight spacecraft, reduction of rocket fuels by using the lightweight solar cells made from nanotubes. It is also used for larger material strength and for the low temperature coefficient of expansion of a lightweight spacecraft. In automobiles, nanomaterials are used for a high-strength metal. It is made by smashing individual nanocluster metal together to form a macroscale hunk of a solid metal. Nanomaterials also increases the fuel efficiency of automobiles with the use of nanoparticles for a cleaner combustion. Nanomaterials are also used in quality paints that has an improved macro and micro hardness, absorption, scratch, and weather resistance. In environmental, nanomaterials are used as sensors for detecting pollution, it can also be used to level harmful emissions and control it by using nanomaterials for harvesting carbon dioxide in the atmosphere and deploy it for industrial purposes. And in textile, nanomaterials are used or applied to water-repellent clothes, which is made by using the nanoparticles of a silica, including the wrinkle-free clothes by using the titanium dioxide nanoparticles and carboxylic acid. Purpose of nanomaterials. Nanomaterials can also be added to cement, cloth, and other materials to make them stronger and get lighter. Their size makes them extremely useful in electronics, and they can also be used in environmental remediation or cleanup to bind with and neutralize toxins.
Properties of nanomaterials. There are two properties of nanomaterials, the physical and the chemical. So, physical properties. A physical property is a characteristic of a substance that can be observed or measured without changing the identity of the substance. Physical properties include color, density, hardness, melting, and boiling points. So, this also includes the shapes, the size, the aspect ratio, the specific surface area, the agglomeration, the structure, and also the solubility. So the example of this in our daily lives are sunscreen, the deodorant, and cosmetics. So we all know that the cosmetics such as gel, foundation, eyeshadows, lipsticks, and etc. because there's so many cosmetics. In chemical properties, a chemical property describes the ability of a substance to undergo a specific chemical change. To identify a chemical property, we look for a chemical change. So, a keyword's chemical change. This includes the structure formula, the composition of nanomaterials, the phase identity, the surface chemistry, and the hydrophilicity. So, in here, the chemical properties, we look for a chemical change. So, the example of these are the boiling points, the melting points, the flammability, the toxicity, and any other chemical property. So, those are the properties of nanomaterials.